We're done.
Whoa, if only there was ways to remember things. Okay, I'll put these both up, guys. And I'll give you a moment to have a crack. Before I talk through those questions, though, what can you guys tell me about arithmetic sequences in a series? What is the difference between a sequence and a series?
1 to 10.
So a sequence is just a number pattern.
Yeah.
An arithmetic sequence is a number pattern where it goes up or down by the same amount each time. And then I think someone said what a series is, but there were like 3 people talking at once. I couldn't quite hear. Sky, what's a series? The sum. So that first question there, an arithmetic sequence contains 10 terms. If the first is 4, the 10th is 30, what is the 8th term? Series.
Sequences.
When we look at sequences, guys, there's 2 types of rules. There's the recursive rule and the general rule. When would I want to use the recursive rule?
Now.
Now?
No.
General rule.
In general, when would I use the recursive rule?
When it's a pattern, like at least 3 or something.
Oh, I think I see what you mean.
When you've got the first one,
Well, both of them you sort of need the first one.
you've got
Not so much.
1 plus 3 or something.
I think you're on the right track. You only use recursive when you want to find them all in order. So if we want to find 1, 2, 3, 4, 5, 6, 7, it's easier to use recursive. If you want to find a particular value, you use the general. The recursive only works if you start at term 1 and go 1 by 1. So for this first one, would we use recursive or general?
General.
General. And what is our general rule? The general rule for a sequence?
n equals
Not n. Tn. D.
Oh wait, what?
Oh, it's a black. C. DCM.
what page does this one say? You can.
This isn't on in the book. This is just I put some questions up. Where can I put 4 in my rule, guys? T1. I know the 10th term is 30. What can I do with that information? Where? Tn. And if I know Tn is 30, what else do I know?
N.
N. What would N have to be? 10. How many unknowns are in that rule now?
1.
Minus 1's a constant. But just D. Just D. So can you rearrange that to solve for D? Once you've done that, can you find T8? Let's do it.
Oh.
Seriously.
Because you keep on talking at me, I don't understand what you're saying. Did you? Oh, no. At the concert I didn't go to. You know I'm recording, right? There is some weird person that keeps commenting on my videos. It's very odd.
Was it entertainment?
No, like their name is Bob Ross, and every time I put up, they're like, "Oh, okay." Because every time it's like another fascinating lesson, and I'm just like, righto. That makes sense then. Maybe. Okay, I'll give you another minute on this one, and then we'll put the answer up. So the 10th is 30 up there, and then down here it says TN, and in the bracket it says N.
Pretty sure I did this completely wrong.
Huh? Called who weird? No, I said it's some weird guy calling themselves. He's not watching the lessons.
T.
Yes. Well, and we know T30 is... Sorry, T10 is 30, Clarice. So you can replace TN with 30 and N with 10. Because this tells us over here, it basically tells us that T10 equals 30. That's what that means. So we can replace TN with 30 and N with 10 and go from there.
Oh, that's cool. What is it? Yeah, it's like, 26 divided by 9, and it comes up with 26.
You can the answer form.
And it's 10. 10.
Julie, is that our first step? Why does it take D?
I mean,
Why is D there?
why is D this?
It can take D.
Yes. Times 10, 10D. Yes. And T times that of 1, make it a D.
Oh. What? I don't know.
What's negative 1 times 9?
1D.
Negative D. 23 first.
Oh.
23. I get it from my friend. How'd you get it? Plus T and just X there's test.
If you don't have to find an answer, just use it.
Yeah, find T8. What's 26 over 9? That's nasty.
Well, I did the D.
What 2 return?
Then, no, 2.888.
So to be clearer with these things, Sajid, huh? Just put a dot means recurring. Normally, if you had like 2.31 and you put a line over it, that would mean the 1 recurs, and that would mean 1 recurs. So it's just where you put it. As long as you just put it over the last one. The dot means just the last one recurs.
Yeah. This is why you're writing with 10.
So guys, you should have found D is 2.8 recurring. For the 8th term, guys, we just say Tn equals T1 plus D, n minus 1. We're trying to find T8 equals 4 plus 2.8 recurring, 8 minus 1. Put that in your calculator, what do you get? I would leave it as a fraction, 26 divided by 9, and then that'll have it exact. So guys, what's T8?
What's in the brackets? Take 1.
Okay, take 1, that's right.
What's this? Yeah.
If I remember.
Questions, comments, concerns?
Wait. What?
Cool. So guys, a new golf club, shouldn't be talking over people. New golf club is formed with 40 members in its first year. Each following year, the number of new members exceeds the number of retirements by 15. So what does that mean?
Every year, number of people who retired, they get 15 more.
Yeah, so it goes up by 15 each year, basically. Each member pays $120 in membership fees. Calculate the amount received from fees in the first 12 years of the club.
Is there a formula?
Sure is.
Good one. We just did.
Nope.
No?
It's different. Yeah.
Nope. What kind of question is this, guys?
Extended.
Nope.
Opposite.
Nope. It is not an arithmetic sequence. Well, it is, but it's not.
It's the geo
It's not geometric. It is arithmetic, but it's not a sequence.
series.
Ashton. Nope.
Series.
It's a series. So, guys, the series is just where you got to add up all of your values. Because can you see, if you want to find the total that this club has earned over that first 12 years, it'll be how much they earned in the first year, plus second year, plus third year, plus fourth year, plus fifth year, etc. If you find how many members were signed up each year for the first 12 years, that'll tell you how many people there have been had memberships. What would you do to find the total amount then?
Is this like a two-step question?
Yeah. Or you could do it in one step.
What's the first step? Yeah.
No?
Finds the
Okay, maybe it would help if we think, if we have an arithmetic sequence, what's the rule?
That's good stuff.
Sorry, series, yeah.
T1 plus T2.
Sn equals
N over 2. Bracket T1 bracket. So T2. T in brackets. I was close. Very far away.
So, do we know what n is going to be?
Yeah, no.
Someone at the back said it?
It's
12.
Oh, yeah.
Do we know what T1 is?
Yes.
40. What are we going to have instead of Tn?
Blank. 15.
What n are we finding?
12.
12. So T12. Do I know what T12 is yet? Can we find it out?
Yes.
T12 is just going to be T1 plus D n minus 1. T1 is 40. What's the common difference each year? 15. What year are we looking for?
12.
If you put that in your calculator, what do you get?
Number that.
Huh? 215 or 205?
Yes.
What does that 205 mean?
That's how much people they'll be by the end of it?
Not recruitments, but that's how many members they have in year 12.
Yeah.
And guys, honestly, this is the biggest advice I can give you. Try not to lose track of the context of the problem. What I mean by that is always know what it is you're finding. It's great if you can remember the rules, but if you can't match the rule to the situation you're using, you're going to put yourself in a bad way. So you need to understand that 205 is an amount of people. Because I can see it really easy for you to go, okay, well, that's $205 because the question was talking about dollars earlier. So you've really got to make sure that you're remembering what each of your variables are.
It's TNT 12.
TNT.
No, TN. Does it equal T12?
So TN is just the general term. We want to find T12.
Yeah.
So T12 is 205, yeah. So if we go to our rule now, guys, I'll just rewrite it over here. Sn equals, instead of n, what are we putting in?
12.
12. Instead of T1, we have 40, and instead of Tn, we have 205.
And then is it as simple as just do that?
Yeah. I'm not making it full screen, so it lets me choose. It's something I started doing in physics, guys. Let me know if you find it helpful, but I'm trying to, when I change a number, I'm doing it in blue. So if I've subbed in or if I've calculated, I'm doing it in blue. I'm doing my working out in green, and then just the stuff that's staying the same is just staying in red. Does that make sense? So, and I'm hoping that might make it a little bit easier to follow what's going on if you like look back over it and you've forgotten the steps. Is there any maths, like is there any rearranging we need to do? No, we can just put it straight into the calculator. What's that give us? 12 divided by 2 is 6, sure. 6 times 245.
Let me.
Where's your calculator?
What small hasn't given it to you?
1470?
So close to that.
Once again, guys, what does that number mean? It's the number of people who have had a membership for the first 12 years.
So now we have to take it. Why? What's he done?
You can draw on his calculator.
What's he done?
So 1470 people have paid for membership. Have we solved the problem? What is the problem asking us to find?
Cost.
The costs, or the amount that they've earned, I guess. How would we find the amount that this club has earned?
Take that.
Lachlan? Yeah. Easy, just times it by 120. So if we go the amount received, yep.
Train spittings. What you can get.
Did you have a question? Because there was 205 people in year 12. So if you add up all the people in the first year who had to pay a yearly membership, all the people in the second year had to pay a yearly membership, third year, fourth year, all the way through the 12th year, in total across those 12 years, 1,470 people have bought a membership across the first 12 years. So our rule to find the sum, so add up all the people from those years, we need T1 and Tn. We only had T1, but we found Tn just by using our sequence rule. So guys, our amount received is our memberships times our cost. Our memberships was 1470. Our cost was 120. Can someone tell me what is that answer?
176,000.
Have we answered the question effectively now?
Yes.
Excellent. Are there any questions or anything anyone would like clarified before we go on to today's work?
Color code the answer.
Color code the answer? Oh, goodness. Why don't I go to this one? Color. What would you like the answer color to be? We're already using green for working out. Yellow might be hard to see. Is that... Can you guys see that?
Alright, so.
We're hitting the real important stuff here. Okay, I'm going to do brown. Well, that's one too many zeros.
164 characters.
Can everyone see brown all right? Really? But if I do this, it's recorded and it's in the OneNote forever, so. Okay. Let's jump over to geometric sequences and series. Okay, so this is page 55. So can you flick to 55 in your workbook, please, guys? Who does not have their workbook here today? Yeah, it's in OneNote, but the point is that you write it as we go.
Yeah.
My goodness, guys.
Oh,
So, listen up. You need to bring to class, at the moment, your laptop. We're probably, after this assignment, we're probably going to drop off on using laptops, so you probably don't need to bring them much past your assignment. You need to bring your calculator. I expect that as we're going through this, you are doing it in your calculator with everyone else. There will be, and every year, there is people that get to the Tech Active and they're like, oh, I forgot how to do this in my calculator. And every time I think about those students in class, and they're the ones that are sitting there just copying off the board, not calculating stuff themselves. The third thing you need to bring to every lesson is your workbook. Yes, it is on the OneNote. Yes, the lesson is recorded. But you need to be getting the notes down. The fact that there's a workbook doesn't mean there's no notes to take. It means I've written out the definitions for you. You still need your work solutions in an easy to find, set up way. I have put a lot of time and effort into that thing. If people aren't going to use it, we can go back to copying notes off the board, which is boring for everyone, especially me. And that's the person I care most about, so I don't want to do that. Okay. Guys, so geometric sequences and series. What is it? Continuation of arithmetic. Easy as. Instead of going up or down by a set amount, we're going up or down by what they call a common ratio. So in other words, it's being multiplied or divided instead of plus or minus. We put the chord down.
only if he gives me the rest of what chord? The chord.
Sajith, give him the rest of his chord.
Yes.
Okay. If you look at, let's say, who am I going to pick on? Young Kurt. Here he is. Kurt. He decides to have 3 kids. Each of his 3 kids also decides to have 3 kids. So on and so forth. Can you see how very quickly his great-grandchildren, there's a gazillion of them?
That's
If-
why there's
55. If each of them then had another 3, you can see how quickly it gets like really out of control. So when we were looking at arithmetic sequences, you could find like T20 and it's not that big. If you find T20 in a geometric sequence, it's either going to be a ginormous number or a tiny one. They get really big really quickly. They get really small really quickly as well, depending on whether you're growing or decaying. Okay. So we have nominally 6 hours for this. Technically, in the content, this is like the last topic, more or less, you're supposed to do. But I figure, seeing as it's basically identical to arithmetic sequences, just a slightly different rule, I like to do them together. So we're going to do this now. There's a couple of different rules you need to know. If we have a look here, guys, our good friend recursive definitions is coming back up. And you should see that this recursive definition is the exact same as the arithmetic one. The only difference is we're timesing by r instead of plussing d. We're going to look at this formula, Tn equals T1 times r to the power of n minus 1. Does that remind you of a rule? Which one? Yeah, the general rule of an arithmetic sequence. In that one, we were doing plus d times n minus 1. This time we're doing times r to the power of n minus 1. We'll look into where that rule comes from in a bit. We're going to look at what happens as you go towards infinity. So if you find like t 1,000, what's going to happen to your geometric sequence? We're going to use the the series, so geometric series. We've got some rules there. So there's going to be 4 rules for this. Recursive rule, general rule, And then there's two separate rules for the series, depending on if you're finding a certain amount of terms or if you're finding the sum of infinity.
We don't have to remember all these, do we?
On the formula sheet.
Where's that?
In the back of your workbook. We're meaning to print some more off. Okay. So previously, we've established sequence is the first term. Can be defined using a first term. There's a common difference. So A or T1 and D. That's for arithmetic. Same thing applies for geometric, so going up or down exponentially. But instead of D, we are using R. Where the way we find R is Tn over Tn minus 1. Can anyone remind me, what do I mean by Tn and Tn minus 1? So, the number you're trying to find, would that be Tn or Tn minus 1? Tn, and then what would Tn minus 1 be? The previous term. So this is where I like to think about it. The current term, and this one is the previous term. Can you see that if from one term to another you just times by R, to get R back you just take that second term divided by the first term. So if you had T2 and T1, the way you find R, divide T2 by T1. You always do the highest number term up top. So it's always T2 divided by T1, or T5 divided by T4, T10 divided by T9. You'd never do T9 divided by T10. Always have the larger term number up top. Okay, we call R the common ratio. And this is our recursive rule. Tn equals T1 times R to the n minus 1. I'm not going to dwell on this too much because it's the same as arithmetic. In other words, the nth term is equal to the first term multiplied by the common ratio once for each jump in the sequence. Okay, let's go through these ones. Which of my sequences are geometric? Let's pretend I had a bracket there. 1, 2, 4, 8, 16, 32, geometric?
Yeah.
What's the common ratio?
2.
2. Next one, 100, 50, 25, 12 and a half, 6 and a quarter, 3 and an 8.
Geometric.
Yeah. Sorry, I should have set up here R equals 2. This one as well. What would my R be here? 0.5.
Right. Used to say right before.
It's not. A lot of people do make that link between the arithmetic. We're not taking away. We're decaying. So when you multiply by a number less than 1, Clarice, it'll go down. So the fact that it's less than 1 at 0.5, that is what's making it go down. You can also have a negative, but then that changes to swap sign every now and then.
So if we use this formula in our physics exam,
It's the exact same as the exponential. It's slightly different for exponential decay.
oh, surely it's raining on me. Oh, yes.
Next one, guys. Is this geometric? 10, 5, 0, negative 5, negative 10? Yeah? No?
No.
No?
Oh, yeah.
Izzy, what do you say? Tyler reckons it's arithmetic. Do you agree with him? What do you think, Zoe? It's arithmetic? What would my common difference be? Negative 5.
Sequence of series.
Yeah, I'm aware that rain happens. How did I know? Because if you look here, it goes down by 5, down by 5, down by 5, down by 5. If I look at this first one, times 2, times 2, times 2, times 2, times 2. Yeah. So you've got to look for, is it going down by the same amount each time? If it is, it's arithmetic. If it's increasing by the same factor each time, it's geometric. So
What are we, series or sequence?
they're series at this point. If I then said to you, find the sum of those 5 terms, that would be it.
Oh,
See,
Okay. D, guys. Arithmetic, geometric. Geometric, what's my R value? Yeah, or... so there's a few ways we could write it. We could write R equals 0.1. We could say R equals 1 over 10. We could say R equals 10 to the negative 1. All three of those mean the same thing. None. But you will see it written, not so much the third way at the moment, but you definitely see it written both as a fraction and a decimal. So you've just got to be aware of that. No, just different. There's a million ways of writing numbers, guys, and we use all of them.
Yeah.
Okay, let's look. So, guys, I know that you're fascinated by rain. We've got a lot of work to do. So find the seventh term of the sequence 3, 9, 27. Let's do this. T1, T2, T3, T4, T5, T6, T7, 3, 9, 27. What's my common ratio, guys? Times 3. I'm going to need someone to tell me this next one. What's 27 times 3?
60. 80.
Next one.
Or 64.
Something wrong with that.
Next one.
Wait, whoa.
It's T.
Yes. And T7.
No.
Sorry. Wait. Sorry? So we can see here, Ryan, that the common ratio is times 3. Times 3. So we're just timesing 3 to go from one step to the next. Good thing Clarice is on the case, honestly. Okay. This one's a bit trickier, guys. This one's a bit trickier.
T4. Oh, now I have to work backwards.
Okay, Lachlan Sam, I'm concerned that I'm seeing you intently looking at your screens. Let's make sure we're focusing up on this, please, guys. Do I have any thoughts? How might we go about solving this one, guys? We know T1 and T4. Use the formula.
Okay.
I haven't really shown you a formula yet, though. So,
Back to brackets.
this is honestly the way I would do it, guys. What is really good about sequences is it's number patterns. It's logical. You can just logic your way to the answer without using a formula. Not quite. We know that T1 equals 18. We don't know T2. We don't know T3. But we do know T4 is 144.
What a square root sign.
How did I get from T1 to T2?
One jump.
What did I do?
I'm times 2.
2? What did I times by?
D.
No, D is for arithmetic. Guys. No. Not quite. You're on the right track, though. Guys, I want you to really think about this stuff. It gets really frustrating, and I don't know if you guys are being serious or just calling out numbers. Because when you go from one step to another in geometric, every time, what have you multiplied by? Someone said it before. Ah. There you go. When I go from T2 to T3, what have I multiplied by? R. From T3 to T4, times R, like a pirate. Would it be correct then to say T4 is just T1 times by r times by r times by r. Do we agree, guys? That is a true statement. I'm not lying. If anything, I'm a tiger.
No.
So I'm not lying. Everyone's a critic. T1, and I'm just going to tidy up that R3, like r times r times r to be r cubed. Times r cubed. And then, of course, I actually know what T4 and T1 are. I've got 144 and 18. What would I do next, guys? Rearrange. What would I get rid of? How would I get rid of it? Divide 18. Divide. We don't have to square root. And I believe that is 8. Now, whose instant thought to solve that is to square root? Why can we not square root? Because it's not square. However, cubed root is the same thing. Now, I'm going to give you some bad news, guys. I expect you to know what the cube root of 8 is. It's 2. I also expect you to know what the cube root of 27 is. Do you want to guess what that is? 3. I also expect you to know what the cube root of 64 is. 4. The reason I expect you to know those things, guys, it is possible in the tech-free exam that you will get a cubed root of 27, of 64, of 8. How do you know?
Just do it in your head.
They give you a ridiculous.
So r cubed means I have some number times by itself, times by itself, times by itself to get 8. There's only one number that would do that, and that is 2. No. Your 2 times tables. 2 times 2 is 4, times 2 is 8. I'll always give it to you as a whole number on your tech-free, but the rule of thumb is 2 cubed is 8, 3 cubed is 27, 4 cubed is 64. So if you see those numbers, you should be remembering, oh, I've seen this cube root before.
So r equals 2.
R equals 2. The way you would show you working out, guys, you would do the cubed root of both sides. Do you guys know how to find cube roots on your calculators?
Isn't it a symbol?
Is it a symbol?
Yeah. Yeah, you can choose.
R equals 2. Can someone show me this?
So they can join the
Answer firing.
Okay, guys. It's the math button. All of the fancy math commands are in the math button. If you scroll down, the first one says arrow fraction. If you have an answer you want to turn into a fraction, button. The next one says arrow decimal. That turns your answer into a decimal. The next one is to the power of 3. If you don't feel like pressing up arrow 3, you do cube that one. I will go up arrow 3 myself, but whatever. The next one is cubed roots. The one after that is x root. So if you wanted to find like the 8th root, you would type 8 and then the x root and then put your answer in 8.
Where do we look at that?
Cubed root.
So when's the exam for this? When's the exam for this cert?
Next term.
Yes.
It's a square, it's a root sign with a 3 in front of it.
This question is for that. Yeah, silly question. My bad. It's different.
Would you guys like to have a go at this one on your own before I show you?
Yeah. We have like 15 or something.
15 minutes. My general class did this question in like 5 minutes today.
Yeah.
Yeah, but Year 12 General is like way easier than Year 11 Adults.
Maybe. So you're gonna go.
I said you could before.
Who wants to do that?
No.
What's the point?
It's the point. Get mass over and done with that. Do it again.
Ryland, why don't we solve this one instead of playing with Clarice's hair?
Six.
Did you say move or come here?
No, it's like Rental weekend.
Yeah, that's nice. 2 weeks. Whoa, hold up. Let me finish it. Don't just pull that answers.
Alright. No, how this bucket works down.
3.
Works down. Age.
E3. And
So what do you know from the question? What does the question tell us?
And it's 80.
So you know T6 is 80, and you know T3 is... You go from T3 to T6, how many jumps?
3.
Before you find T1, what's in these reports? T doesn't mean any. You have one. So you know that 3 jumps, you went from 10 to 8, so you can figure it out. Was it 10 to 80? Yeah.
Yeah. Sorry?
What do you mean? Does this have to do with this question?
I think so. Wait. What? How is it going to be basically the exact same?
How we going, guys? Are we ready to go through the answer? I see a couple of us.
So can we have like 2 more minutes to find out the 10?
A couple of us have found R. Once you've found R, it's really easy to find T1. I don't really care about generating the first 10 terms of the sequence, so you can skip that bit. I just want you to find the general rule.
Is it just
Survive inside.
what to get together first? Oh, yeah.
So get to T6.
Thanks for that, Stuart. All the time.
Oh, yeah, that's a fact.
Could you say T6 equals T3 times?
I've been written thing. So what's that equal? T6, T3.
I go with T3.
No,
Because that's true, isn't it? You start at T3 and you do 3 jumps to get to T6.
T3 what? Symbol 1.5.
As a geometrically times each.
so that's right.
How are we going to do this?
You mean?
What is it, Jiggly?
You get rid of it.
It's so quick, too.
Say silly French.
See what's the apple
you says. Anyway, how are we going to Where's my
We need a live equation. How's the joke go around?
Right, now.
But anyway,
Is this the exact same C3 negative?
Yep.
Cell.
What? Alright, it's T3 divided by 2 to the power of 2.
What? It's T3 to the power of -2.
Power of 2.
-2.
Divided by 2 to the power
Why
of
are
2.
you saying two?
It's like method.
So, are you trying to find here?
Remember that question?
So, you know to get back to T2, you have to
What's 10 divided by 2?
Where's to the power?
then divide.
By
That's how. What did you do? How do I go back now? I'm going to
I'm gonna divide. Why are you doing 10 to the power?
Is that negative or is that?
No, negative is that. Why are you doing 10 to the power of?
Because that's T3.
Gone.
What? How do you go to decimal?
Is that your answer?
Decimal.
Yeah.
What? Go to decimal point.
You're in.
Yeah, and in this case, R is.
This would be but
Do you do manual? See that?
Okay, guys, let's go through this one. Shh. I know that to get to T6,
let's stop.
I can start at T3, times it by R 3 times. T6 is 80. Sorry, I should be using my colours. We know that T6 is 80 and T3 is 10. To solve for R, guys, I'm just going to divide both sides by 10, which gives me 8 equals R cubed. And seeing as we just did it, guys, I'm happy to skip straight to R equals 2. Cool? There's a few different ways you can then find T1. You could, if you wanted, you could say, okay, well, if I'm going to go start at T3 and go backwards, how would I get to T2 going backwards? Divide by R, divide by... So you could do it visually like that if you wanted, and that would be a correct answer. That would be correct.
We're divided by 10 to the negative.
Thanks, guys. I'm going to do it using a rule, though, because I think recognizing how to use rules is really important. So, similar to the equation I just set up there, I know that if I want to get to T3 and I start at T1, how many jumps do I have to do? 2. Jump once to get to 2, again to get to 3. And then I can sub in my values. So I know T3 is 10, and I know R is 2. I know 2 squared is 4, so I'm just going to divide both sides by 4. Which is the exact same thing as we would have done doing it visually anyway. So I know T1 equals 2.5. So therefore, guys, Tn equals 2.5 times 2 to the n minus 1. I don't know why it's doing the cursive writing thing again. But
I wonder if it's a load.
Maybe.
T1
T1 is 2.5. Common ratio is 2. Make sense? Excellent. Do we need this up for another moment? You could do it a different way if you wanted. Do you mean the last part as in writing out Tn? I didn't specifically tell you to. Why did I divide by 4? Because 2 squared is...
usually. Go back to this stuff.
Okay, guys. We're going to go through these ones together. We're pretty close to... Yeah. We'll go through these ones together, then I've got some for you to practice for the last bit of the lesson.
Looks good.
Can anyone look at that question and pull out the important information in regards to T1 and R for me?
Before.
So what would that be?
TN.
So you think Tn is 1.5 times larger. That would be R. What else? What other information is in the question? So first triangle has side lengths of 4 centimeters. So that would be T1. So therefore, my rule, guys, would be Tn. In this case, what does Tn represent?
Final.
The side length of the nth triangle. Tn equals 4 centimeters times 1.5 to the n minus 1. Do we have all the information we now need to answer question 1?
Yeah.
No? What are we missing?
And
But if we're trying to find the side length of the fifth triangle, would n be 5?
yeah.
We want to find the fifth triangle. Because I like to think of that as the number of jumps. If I want to find the fifth triangle, that means I've increased its size 4 times. Because the first one is just the size it is. The second one has been increased. Third one increased. Fourth one increased. Fifth one increased. So 4 jumps. So what that really means, right, is we're timesing by 1.5 4 times. And that'll get us the side length. So for question 1, guys, we're just finding when n equals 5. So we have Tn equals 4 times 1.5 to the 5 minus 1. Is there anything special we need to do, or can we just chuck that straight in?
Chuck it.
Chuck it in. Sky, what have you got? Did you get an answer for that one?
6 to the power of 4.
6 to the power of 4.
Is that 8%? Good
I don't care.
Really? Actually, 64 times 64. I can't think.
So what's my answer, guys? I don't know. I'm asking you. Is that what your calculator said?
Yeah.
Okay. How do you do what, Cruz?
Isn't 4 times 1.5?
So press the up arrow, and it should automatically put a little box there and just write it too.
I think I know. 1.5. I think it's done. 1.5 to the power of 4 and
Oh, yeah.
I think power is yeah, it could be. Let's go.
It's 3 times 3.
8. 7? What's 7 times 7?
It was
29.
What does that 20.25 represent, guys? Okay, can we put our conversations on hold because they're getting really annoying? What does 20.25 represent? And what is T5?
Sequence.
The side length of the fifth triangle. So what should my answer be in? Centimeters. This is what I mean, guys. You always need to keep track of what the question is asking you and what you're finding. It's really what separates the students that get A's from the students that get C's, the ones that can keep track of what they're doing. And I'm not even exaggerating there. The students that can keep track of what they're doing generally score the top marks, and the students that are just formula, numbers, here we go. And don't follow through what they're doing. They're the ones that tend to not do so well. Let's do question 2. Which number triangle has a side length of 45 and 9/16 centimeters long? I would. What does that number represent? 45, 9, 16 centimeters. What does that represent? Not SN.
TN.
SN is only if we're adding up all of the terms, which in this one we're not doing.
TN.
So it would be TN. So TN equals 45. Now, do you know how you would put 45 and 9/16 into your calculator? Yes. You said that in a weird way, but yes. Plus 9/16. So basically, there's your whole number, there's your decimal. You can put that in. If you were putting that in, though, and you had to operate on it, you'd probably put it in a bracket. If you wanted that as a decimal, 9/16 isn't too bad of a decimal. You can just do 9/16 in your calculator. It'll give you the decimal as well. Okay. What other values do we need to know for our formula? We've got Tn. Do we have T1?
Yeah.
Do we have R?
Yes.
Yes. Do we have N?
No.
No, N is actually what we're solving for.
So we can just rearrange
Yes.
Sort of.
using the logarithm.
So we've got T1 equals 4, R equals 1.5, and N equals question mark. I will explain it in 1 minute.
Issue.
So 45 and 9/16 equals 4 times 1.5 power of n minus 1. Now, what is the issue with solving this one, guys?
Yeah. Well,
N is tucked away in the power. So there is an issue with solving this with the maths we know now. Now, this unit, I will teach you how to use logarithms. I'm not teaching you that today, though. So we're not going to be able to solve this by hand, but luckily, our calculators are really good at solving for things like this. So, my graphics calculator has disappeared. But what I want you to do is, in your graphics calculator, I want you to go to that numerical solver. So math, solver, y1 equals 45 and 9/16. y2 equals 4 times 1.5 to the x minus 1. And then solve. Numeric solver. I'll get my calculator up and show you on mine as well. What's it called? No, it's Smart View. Smart View. Yeah, graphics calc. Next time I do this, guys, just remind me when I forget what it's called. It's called Smart View. Because I always try and search calculator or graphics calculator or whatever. No. I cannot. There we go. Ooh, I have 83 days left of my free trial of this emulator. Okay. See the button my mouse is hovering over there?
That way.
The variable button. Okay, so what we do, guys, math. Your numeric solver should be at the bottom. It's called solver. For equation 1, what did I say I wanted it to be? 45 plus 9/16. And for equation 2...
do you have to add brackets?
Not for that one, no. 9 divided by 16. For where? 45 plus 9/16. Equation 2, would be, what was it? 4 plus 1.5 to the power of... Yes, it is, sorry.
So where to get back to? If you put n instead of x, would that change it? 4 times 1.5.
Okay. Does anyone remember the trick with solving this? If you just press enter, will it work? You've got to press solve. So you've got to press this button here, the button under OK.
So
X equals 10. It depends. Sometimes it won't. It'll always work if you press solve.
unlucky.
Cheers, Lord. So did you press enter?
Just the things outside.
Yeah. Not really.
Yeah, so yours haven't actually solved it yet. That's just the last answer.
Are you gonna get a permanent mark? Specialist on one. So get that intellectually. Intellectually, you got that.
Back in the
Hold
like this.
I use it. So it's not his work. So we'll give you better
on the other calculator, sure.
You want the whole thing.
It is gonna stop raining, isn't it?
Yeah, obviously.
Straight away.
Yeah. Maybe when you calculate checks the way it's like.
Without it 49, whatever. You will get 0 minus 4. It would be.
Yes. Sky.
But what else? I have been with the phone. Why? What's the
What do you buy for the power of one? How do you put anything money to?
Monday. Correct that. Some of them really good. Watch that television at the time. We'll get it back, get it again. Medium. I would change it like a. I plan today is like. Oh.
Maybe.
Yeah.
How quiet it is.
Tells you how.
Guys, for some reason, I've seen a couple of different answers. I've seen mine said x equals 10.
Yeah.
I've seen some people's have said x equals 7.
6.96.
There's a way to check. I'm not sure why we're getting different ones, but remember there is a way to check. So I want to put this into my equation. And then we will, so I'll quit out of that. Just second quit. And I'm going to make my equation up here. 4 times 1.5 to the power of x minus 1. Whoops, my x didn't work. X minus 1. Okay, and sorry, that's I'm just trying to make it so you can also see it on the recording.
Whoa.
Oh.
Okay.
Yeah, go back.
I'm just trying to make it so it's also on the recording, that's all. Okay. Okay. Y equals the top left button. So I've got my function here, guys. Yes? If I then want to see what it is at x equals 1, 2, 3, 4, 5, what do I press? Does anyone remember? No? Do we want to see a graph? We want to see the table. So second table. So term 1 is 4, then 6, then 9, then 13.5. Term 7 appears to be the correct answer.
25.56.
25.5 or 45.
Yeah, I think
So, I put y equals just as my rule. 4 times 1.5 to the power of x minus 1. Guys, I'm not sure why the solver isn't working.
maybe it's just
It should be. Look, that is. I was going to say no, but that is possible. Let's have another look at the way I've done it. Let's go into my solver. Guys, I was hoping to get you guys to practice a ton today, but we'll do that tomorrow. What if I put...
Does that have to be?
I would like to be printed, yes.
and
So, you don't have a printer, but you have access to a school with many printers. Not this week, that's next week. So if you go to the library, log on, email it to yourself. Yeah, guys, I'm not sure why that solver's mucking up. I'll investigate that a bit, the Savo, and try and figure out why it's mucking up.
So are you at Hub the Sub?
I am at Hub the Sub.
Looks